Welcome learners to this session. Welcome all, welcome once again. Today we are going to have a discussion on differentiation and linear motion. Keep updated dear learners. So we start with question number 1. That is question number 21 on differentiation. That the displacement s meters of a moving particle after t seconds is given by the displacement s meters of a moving particle after time t seconds is given by s is equals to 2t cubed minus 5t squared plus 4t minus 3. Determine the velocity of the particle when t is equals to 4. Determine the velocity of the particle when t is equals to 3. Dear learners, that is very easy, because for us to determine the differentiation, for us to get the differentiation, remember that this is an equation for displacement. It's an equation for displacement, and they are talking about velocity. So velocity is obtained when you differentiate displacement with respect to time. You're going to get velocity, that is ds over dt. When you're differentiating, learners, you drop the power down, then less the power by 1 to get the new power. So that's going to be 6t squared minus 10t plus 4. That is the equation for velocity. But now they say that determine the velocity when t is equals to 4. So we come here and say when t is equals to 4, v is given by, we are going to replace t with the value 4. So this is going to be 6 into 4 squared minus 10 into 4 plus 4. Then with the aid of our calculator, we do replacement. This will be 6 into 4 squared minus 10 into 4, then plus 4. You get v is 60 meters per second. 60 meters per second. So when t is equals to 4, v is 60 meters per second, learners. That's how you answer that question. Roman 2 of the same question, part B, sorry. The value of t when the particle is momentarily at rest. Now, dear learners, what we should know is that when the particle is at rest, there is no velocity. So v is equals to 0. Learners, in this case, at rest, you should know that v is equals to 0. Now, because we know that now v is equals to 0, learners, what are we going to do? We are going to take the equation for velocity, which we obtained after differentiating in part A, as 6t squared minus 10t plus 4, and we equate it to 0 because the particle is at rest, so the velocity is 0. Now, after realizing that velocity is 0, we are going to solve this. So we are going to look for two numbers such that the sum of the numbers is going to give us negative 10, and the product of the numbers is going to give us 24. What are the numbers? The sum giving you 10, and the product giving you the product giving you 24. The product giving you 24. The number should be rotating between 6 and 4. And for the sum to be 10, then it's -6, -4. Those are our two numbers. So upon substituting, we're going to have 6t squared. We are going to substitute into the b number. So it will be minus 6t minus 4 plus, sorry, minus 4t plus minus 4t plus 4 being giving you 0. So this is 6t into t minus 1. That will be minus 4 into t minus 1, giving me a 0. Those without inside the bracket, those that are outside the bracket, we put them in one bracket, such that we will now be having 6t minus 4. Then those inside the bracket, because they are similar, we are going to pick only one set, t minus 1. Then we equate it with a 0. We get it with a 0. So for the first case, we are going to have 6t minus 4 equals to 0. 6t is equals to 4. Therefore, dividing through by 6, we are going to get, dividing through by 6, we are going to get 6. Sorry, t is equals to 2 over 3. Seconds, t giving me 2 over 3 seconds. For the next case I'm having, t is equal to, sorry, t minus 1, t minus 1 is equals to 0. So this means t is equals to 1. T is equals to 1. So they want the value of t when the particle is at rest. So it means t is either 2 over 3 or 1. Because all the two values are positive, so we are going to pick all the two values, learners. We're going to pick all the two values. Let's look at part C, the displacement when the particle is momentarily at rest. The displacement when the particle is momentarily at rest. Now, we've known that the particle is at rest. So we've known that the particle is at rest. The particle is at rest when t is equals to 2 over 3 or 1. So let's get when the particle is 2, so let's see, when t is equals to 2 over 3, what is our s, which is the equation for displacement? We're going to do that replacement there. So remember that s is being given by what? S is being given by 2t cubed minus 5t squared plus 4t plus 3. So this is going to be 2 into the value of t, which is 2 over 3 cubed minus 5 into 2 over 3 squared, then plus 4 into 2 over 3 plus 3 plus 3. This is giving me the value of s as what? Let me replace into my calculator. Let's all replace. That is 2 into 2 over 3 close cubed minus 5 into 2 over 3 close squared, then plus 4 into 2 over 3, 4 into 2 over 3, then plus 3. What are you getting, dear learners? Very, very important to know what you are getting when you key in. When you key in, what are you getting? What are you getting? I'm getting on my side, I'm getting 4 1 over 27. For whole number 1 over 27 meters as the value s when t is equals to 2/3. What about when t is equals to 1? When t is equals to 1, comma, s is being given now by, s is being given now by, that is 2 into 1 cubed, then minus 5 into 1 squared, plus 4 into 1 plus 3. When you do the replacement, learners, when you do the replacement, that is that is cubed minus 5 into 1 squared minus 5 into 1 squared plus 4 plus 3, you are going to get 4. You are going to get 4 meters. So those are the displacements, and that's how you answer that part. The acceleration of the particle when t is equals to 10. Learners, how do you get acceleration? When you differentiate velocity with respect to time. Remember, acceleration is obtained by saying dv over dt. When you differentiate the equation for velocity, remember velocity you have 6t squared minus 10t plus 4. So when I differentiate it, I'm going to get 6t minus 10. 6t minus 10. Now, I now come and say when t is equals to 10, comma, acceleration will be equals to 6 into 10 minus 10. That is 60 minus 10, which gives me 50 meters per square seconds. 50 meters per square seconds. 50. Just hold on a bit. How have I done my differentiation? I've not done it well. Apologies. There's something I've omitted. Sorry. When you differentiate velocity, the equation for velocity was this 6t squared minus 10t plus 4. Differentiating, you drop the power down, so 2 times 6, that makes it to be 12. That makes it to be 12t. Then now minus 10. That's how we differentiate that equation. So when t is equals to 10, acceleration is being given by 12 into 10, that's 120, minus 10. This is going to give me 110 meters per square seconds. And that is a question on differentiation. That's a question on differentiation. Keep sharing the link, learners, with other people also, so that they can watch and learn. Let's look at question number 22, which is our question 2 of discussion in this session. And the question is from Form 2, linear motion. So any Form 2, any Form 3, any Form 4, who is or our exam has to take this on a serious note. A bus left Bondo at 8 a.m. and traveled towards Kisumu at an average speed of 80 kilometers per hour. At 8:30 a.m., a car left Kisumu for Bondo at an average speed of 120 kilometers per hour. Given that the distance between Bondo and Kisumu is 400 kilometers, part A of the question, calculate the time the car arrived to Bondo. We have two places here. I have Bondo, I have Kisumu. Bondo and Kisumu. A bus left Bondo towards Kisumu. I have a bus. It left Bondo at 8:00 a.m. and it was moving at a speed of 80 kilometers per hour. At 8:30, a car left Kisumu. We have a car. It left Kisumu at 8:30 a.m. and it was moving at 120 kilometers per hour. The distance between the two places is 400 kilometers. Let's calculate the time the car arrived to Bondo. The car arrived in Bondo. For the car to arrive to Bondo from Kisumu, then that car has to travel a distance of 400 kilometers, learners, because from Kisumu to Bondo it's 400. But our car was moving at a speed of 120 kilometers per hour. So first of all, let's get the time taken by the car, the road. Time taken, time taken is equals to distance over speed. The distance the car had to cover in order to reach Bondo was 400, and the speed in which it was moving, it was 120. So dividing 400 learners by 120, dividing 400 by 120, you get it is 3 hours 20 minutes. The car took 3 hours 20 minutes in the road. Now, after knowing that, let's get the arrival time. Arrival time is normally obtained by taking departure time plus the time taken. So the departure time, the car departed at 8:30 and it took 3 hours 20 minutes on the road. So if I have 8:30 here plus 3 hours 20 minutes, this is 0, 5, 11:50 a.m. That is the car's arrival time. The car's, that is the time the car arrived in Bondo. That is the arrival time of the car to Bondo. Next we are having the time the two vehicles met. The time the two vehicles met. So first of all, let's see. Because the bus began the journey earlier, let's get first the distance covered by the bus before the car began the journey at 8:30. So let's get the distance covered by bus. Distance covered by bus. First of all, let's get distance. In order to answer this question, we are going to get the distance covered by bus at 8:30. Distance is obtained by taking speed of the bus, which is 80, times the time from 8 to 8:30, that's half an hour. So you'll get it covered 40 kilometers. The bus had already covered 40 kilometers before the car began the journey. So because it has covered 40 kilometers and these vehicles are approaching each other, we have the remaining distance. Let's get the remaining distance. Let's get the remaining distance. To get the remaining distance, you take the total distance 400, you subtract the distance that has already been covered by the bus, 40. This is going to give you 360 kilometers. After we've obtained that as the distance, let's also get what we call now the relative speed. For the relative speed, for the relative speed, vehicles are approaching each other. The relative speed is going to be obtained by addition. The relative speed, you add the individual speeds. The speed of the car was 120 plus the speed of the bus, which was 80. So the relative speed here is 200 kilometers per hour. 200 kilometers per hour. That is the relative speed. Now, after getting the relative speed, let's get the time taken the time taken to meet. Please also compute time taken to meet. For the time taken to meet, you take the remaining distance. You take the remaining distance all over the relative speed. That's how you get the time taken to meet. The remaining distance for them to meet was 360 over the relative speed which we've obtained as 200. In your calculator, dividing 360 by 200, you are getting we are getting 1 hour 48 minutes. 1 hour 48 minutes. That's the time taken by the two vehicles to meet. Now, after we've obtained that, to get the meeting time, learners, can you be keen here? Now we are getting the meeting time. You take the departure time of the last vehicle. Look at the bus and the car. Which one departed last? It is the car, which departed at 8:30. So you always take the departure time of the last vehicle. I'm insisting on that. The departure time of the last vehicle, which is 8:30, not the departure time of the first vehicle. So you take the departure time of the last vehicle plus the time taken by the two vehicles to meet. That is the 1 hour 48 minutes. When you add 30 and 48, you're going to get 78. You cannot write 78. So you less that from 60, you are going to get 18. Then you carry 1 hour to this other side, making this one 10. 10:18 a.m. So your answer is going to be 10:18, 10:18 a.m. That is the meeting time. That is the meeting time. Part C of the question, the distance from Bondo to the meeting point. Let's see the distance from Bondo to the meeting point. If they met at 10:18, which vehicle is moving from Bondo? We get the bus moving from Bondo. So the distance from Bondo to the meeting point is just like the distance covered by the bus at 10:18. So let's get the distance covered by bus at 10:18. Distance covered by bus at 10:18. Distance covered by bus at 10:18. Distance, you take speed of the bus. Which speed was the bus moving in? The bus was moving at 80 kilometers per hour. 80 kilometers per hour. So that is 80 times the time. Remember, we are talking about 10:18, but the bus began the journey at 8:00. When you subtract this, this is 18. 2 hours 18 minutes. So 2 hours 18 minutes. 2 hours 18 minutes. When you convert it into full hours, you are going to get 23 over 10. So this is like same times 23 over 10. 23 over 10. When you multiply that by 80, you are going to get 184 kilometers. 184 kilometers. That is the distance from Bondo to the meeting point. As simple as that. As simple as that. Let's look at the next one. The distance of the bus from Kisumu when the car arrived in Bondo. The distance of the bus from Kisumu when the car arrived in Bondo. Remember, the car arrived in Bondo at 11:50. So when they say the distance of the bus if they say the distance of the bus from Kisumu when the car arrived in Bondo, they are simply referring. Let's get the distance. First, let's get the distance of the bus at the arrival time of the car to Bondo, 11:50. So let's get the distance of the bus at 11:50. Distance covered by bus at 11:50 a.m. is the speed of the bus. The bus was moving at a speed of 80 times the distance of the bus at 11:50. The bus began the journey at 8 a.m. So if the bus began the journey at 8 a.m., when I take 11:50, I subtract 800:05. This is 3 hours 50 minutes. 3 hours 50 minutes. So that's like saying 23/6 times 23/6. This gives you the distance as 3/6 2/3 kilometers. So that is the distance that the bus had covered at that time. But the question is, calculate the distance of the bus now from Kisumu. The distance of the bus. You remember the bus was moving from Bondo. From Bondo at 11:50, the bus had covered 3/6 and 666 kilometers. So how far is it from Kisumu? You less that from 400. We subtract that from 400 to get the distance from Kisumu. So to get the bus distance from Kisumu, I'm simply going to take the total distance, which is 400. Then I'm going to do that subtraction. So I'll have 400. I subtract 306 and 2/3. When I do the subtraction, I'm going to get 93 and a third. 93 and a third kilometers, and that is the distance of the bus from Kisumu when the car arrived in Bondo. Thank you for being part of this session. We've revised the two questions I intended, that is on differentiation and linear motion. For any inquiries, any consultation you might need, please don't hesitate to reach out to our hotline number, that is 0741304311. Make sure you subscribe to the channel if you have not, and you've hit the bell icon so that to keep getting updates whenever we make a new post. Thank you. Share the link widely with your friends so that they can also benefit. Thank you a lot, learners. See you in our next session. See you in our next session. Thank you.